Today I'm going to show you how to build a bow tie antenna out of scrap materials. It will also support the dual band functionality that some routers have. By the time you finish with this video, you'll be able to transmit Wi-Fi to all the phones in your house. And if you're successful, maybe your aunts, your uncles, your neighbors, your cousin, your doctor, and who knows who else. A list of the items you'll need will be displayed now. Please pause the video so that you can see what they are.
Boots check, tool belt check, hard hat check. Up the builder, can we build it? Up the builder, yes we can.
Step 1 is to take a can opener to take the edges of your can. Then we will take can cutters and cut open the can. The can will seem very rounded. To fix this problem, we will hammer the tin until it is flat. Now we are going to draw the dimensions of the antenna onto the tin. Our antenna will be 140 millimeters long, 100 millimeters high, and we will have an angle alpha of 90 degrees. To obtain this alpha of 90 degrees, we need to have that section be 50 millimeters long and the center of the antenna be 40 millimeters long. It is important to note that any antenna can be scaled according to the frequency that it needs to operate under. The antenna I am building has been modified for a different purpose. Follow the dimensions that I have shown in the previous diagram.
Can we dig it? Yes. Can we build it? Yes. Can we fix it? Yes. Up the builder, can we build it? Up the builder, yes we can.
Now that you've cut your template, you need to fold in the edges of the antenna. As you can see, I used pliers and a cylindrical object to bend the antenna into place. Now it's time to strip our coaxial cable so that we have 2 millimeters of the inner braiding and 2 millimeters of the inner conductive cable. It is very important to note what SMA connection you have on your router. If your router is reverse polarity, you'll need to find a reverse polarity connector, and vice versa. Now that we have stripped our cable, we need to solder it onto our antenna. Before we can solder anything, we need to drill holes into the antenna. The center hole needs to be the largest as it has to fit the whole coaxial cable. The next two holes will be on either flap. The first flap needs to fit in only the inner conductive wire. The second flap needs to fit in the inner conductive wire, the insulation around that, and the copper braiding around the insulation. I would recommend you to take the braiding within the coaxial cable, wind them together, and solder this so that it looks like one unit. This will prevent messy soldering from occurring. After you've done this, you want to solder the coaxial cable to the antenna. First solder the outer braiding to the one side and then solder the inner conductive wire to the other side of the antenna.
Up the builder, can we fix it? Up the builder, yes, yes we can. Up the builder, can we fix it? Up the builder, yes we can.
Now that we have our constructed antenna, it is time to test it. The antenna was measured in the garden. This minimized interference. A program on the laptop was used to measure the dBms received through the antenna on the laptop. The measured results from the antenna and the dipole that originally comes with the router are displayed now. I hope you enjoyed the tutorial and that you come back for more. Thank you.